So good afternoon all. Okay. So good afternoon all. So in the yesterday class we have seen the ECC recorders. So how the ECC recorder it will be connects to different parts of the uh, different blocks of the ECC machine, and so how the different functionalities of the amplifiers, preamplifier and the driver amplifier. So today we will see the measurement of blood flow. How we can measure the blood in a vessel of the blood vessel of a human being. So there are number of methods are there. So there are different methods are there. So electromagnetic induction, ultrasound transmission or reflection, thermal convection, radiographic principle, indicator, dye or thermal dilation methods. So first of all, what is the necessity of measuring the blood flow? What is the need of measuring of the blood flow rate? So actually the blood will be transferred to the entire human body through blood vessels. Okay, so it reflects the healthiness of the human body. Okay, if there is any problem is occurred, it reflects the all the organs of the body will be resist the blood, and those organs will be converts the resist the oxygen and the nutrients in the blood, and converts and replaces the oxygen into deoxygenated blood. Okay, in such situation, so depending upon the condition of different organs, working of different organs, so that organs, it means organs different parts of the body. Okay, so those different parts of the body will be produces uses the blood, and it will be releases the blood, and in such situation, if the any organ is not worked properly, suppose any part of the body is not functioning properly, then it reflects on the it reflects on the condition of the blood flow. Okay, so the velocity of the blood flow may be changes. So like that, to diagnose the condition of the different organs of the body, so it is required to measure the blood flow in blood vessels. Okay, so generally these are the applications of blood flow measurement. So clinical application and research applications. So clinically we can test the blood. So for testing purpose, so while doing the surgery, it is required to measure the blood flow. I mean flow velocity. So how much flow velocity it is moving. Okay, so that is required while doing surgery. So in such situation, clinical and research applications, we can use the blood flow meters, and these are the different principles are used. So electromagnetic principle, induction principle, ultrasound transmission and reflection principles, thermal convection, radiographic principle, and indicator principle. Okay, based upon these 5 methods, um, we can use to measure the blood flow velocity. Okay, and out of so here we can measure in terms of volume per minute. So flow rate will be measured. So how much of volume of blood is moved in a given period of time. So for a given amount of time, period of time. So how much volume of the blood? So in the volume, so in the case of a volume, we can consider as a centimeter cube per time. Time is in seconds. So seconds or in minutes we can consider. So volumetric flow meter. So we can measure volumetric flow. So volumetric flow means how much, how amount of, how volume of the blood will be moved in a given period of time. So that is the units we can consider the blood flow measurement. Blood flow measurement. So we can say it is a flow rate measurement. Flow rate. Flow rate is nothing but it is movement of the flow for a given time. So with respect to, if we measure with respect to time, so it becomes as a rate. So blood flow rate. Okay, measurement of the blood flow rate with respect to time. So will be considered units. And coming to the first one, electromagnetic induction principle based blood flow meter. So electromagnetic blood flow meter. So here, so before going to the block diagram of magnetic blood flow meter, first of all we have to know the what is the principle of blood flow meter, magnetic blood flow meter. So it is based on the electromagnetic induction principle. So electromagnetic induction means, suppose here we have uh, suppose here we have a magnetic, here we have a magnet which is having north and south pole. So the basic principle is whenever a conduction wire is placed in a magnetic field, okay, so it will be induces a EMF which is which is proportional to the amount of the current flowing through the wire. So generally, general electromagnetic induction principle is whenever a current carrying conductor, is placed in a magnetic field, whether it is permanent magnet or electromagnet, so the EMF will be induces the other sides of the wire. So that is proportional to the velocity of the current which is flowing through the wire. Okay, here we have a magnetic flux is there and a current carrying conductor is there. Okay, and that current carrying conductor is in between the magnetic field, and whenever the magnetic field will cut the current, so there is EMF will be induces the other sides of the wire. When we will connect that particular points, we will get the output voltage. So that generated output voltage is proportional to the velocity of the current flowing in the wire. So the same principle is also applied to measure the blood flow in blood flow using magnetic principles. So here, so this is it is a blood vessel, and inside of blood vessel there is a blood flow movement is there, and for this vessel we will have a contact with some contact. So okay, so this type of will other contact is other side of the this vessel, and this vessel is placed between the magnetic flux, magnetic permanent magnet, we can use permanent magnet or electromagnet. Okay, so by placing a vessel, blood vessel which is having a blood flow, blood flow having a flow of the blood, okay, and it will be in between the magnetic field. It means whenever the magnetic field will cuts the blood inside the vessel or blood vessel, so that causes the generation of the output voltage. That output voltage is proportional to the amount of the velocity of the flow of the blood, the velocity of the flow of the blood. So how much velocity it is moving. So that velocity, depending upon that velocity, the generated voltage will be the obtained voltage will depends upon the velocity of the blood flow. Okay. So here the generated voltage will be measured by using meter. Okay, deflection meter. This deflection meter will be shows the generated voltage, and this generated voltage is proportional to the blood flow rate which is flowing in the blood vessel. Okay, so directly, so the obtained meter shows the value shows in the meter will reflects the blood flow rate in the vessel, so we can directly read the value. Okay, so this is a basic principle involved in magnetic blood flow meter. Magnetic blood flow meter. Okay, so generally, in the place of permanent magnet, we can use the electromagnet. So for that electromagnet, it means we will connect a wire here. Here we will place a wire. We will wound the wire around this C-shaped magnet. So this is magnet. For magnet, no need to connect, no need to use the wound the wire. So magnet is a permanent magnet is directly produces the magnetic field. So when we are going to use the electromagnet in place of magnet, so we have to use a wire which is wound around the core, magnetic core. Okay, and whenever we will apply the input signal to this core, so it will be produces the magnetic flux according to the applied signal, and that will be reflects on the obtained received signal. Okay, or induced voltage. Okay, suppose we are applied in the place of magnet, we are using a electromagnet. For electromagnet, we have to wound a wire around a core, magnetic ferromagnetic material will be there. That for that ferromagnetic material, we will around we will wound the wire. So by that, what happens? Whenever the signal or waveform, whenever the voltage is applied, suppose here this is the waveform which is applied to the uh, electromagnet. So by that, okay, so when we apply the that waveform to this electromagnet, so according to that the pulses or magnetic flux will be generated, and depending upon the velocity of blood flow, the flux will be makes the cut this blood flow, and due to that the EMF will be induces. So that the induced EMF will reflects the applied input waveform, some input waveform. So that will be, see here. So this is the applied magnetic waveform for the electromagnet. For that, by applying this, so at the induced voltage is like this. So there is some phase difference is there. So there is 90 degrees of phase shift. So to differentiate or can make the variation of the applied signal and the received signal, there is some time lag will be there. So that's why there is some difference will be there. Phase shift is there. Okay, the 90 degrees phase shift will be there, and whenever we apply a pulsed input signal for the magnet, so we will get the spikes here, spike output. Okay, for upward direction of the pulses, we will get the upward spike, and downward for downwards again we will get the downward spike. Okay, So, but there is a difference of 90 degrees phase shift. There is a difference of 90 degrees phase shift will be occurred for the um, applied input signal and the received voltage signal. So uh, this is the trapezoidal signal. So generally three types of pulses or three types of waveforms of the signals are applied for the electromagnetic blood flow meters. So with this we will get the as an output in these shapes for these applied waveforms. So here, see here, this is a magnetic current. The current is in the form of sinusoidal signal. The current in the form of the pulse waveform, and here it is in the form of trapezoidal form. Trapezoidal form. By applying this current to electromagnet, the induced EMF, the induced EMF, the induced EMF at the outer periphery of the blood vessel, the induced EMF at the outer periphery of the blood vessel is in this form, and having a phase shift of 90 degrees. Similarly, this is also having phase shift of 90 degrees. So with this we can compare. Okay, so how much time it will be receiving? So depending upon the induced voltage, is depends upon the blood velocity. So the induced voltage, the amplitude of the induced voltage, at the output depends upon the blood flow velocity. If the velocity of the blood flow is increased, then the amplitude of the output will be increases. If the amplitude the blood flow velocity is increases, then the generated or induced EMF amplitude also increases. We will get the higher voltages. Like this, we have uh, principle, and we can apply the waveforms. And this is the block diagram of the magnetic blood flow, and this is the uh, block diagram of magnetic blood flow meter. So here we have, see here, this is what I was explained previously. So in place of permanent magnet, we have a ferromagnetic material, and that ferromagnetic material is wounded with a coil. A ferromagnetic material is wounded with a coil. So at this moment, so for this coil, we will give the what was explained here, waveforms. So signals, we can apply this type of waveforms, voltage or current will be applied. So that current will be generated from the oscillator. So here the oscillator will produces the oscillation signals. So depending upon the type of the waveform what we are using. So suppose we are using to sine wave signal, the oscillator will generate a sine wave signal, pulse signals, pulse and trapezoidal signals. So those different types of waveforms are generated by the oscillator. This oscillator will generate the oscillation signals, and those oscillation signals are converted into the current signals. Okay, so those current signals will be applied to this coil. So then what happens, depending upon the type of the signal we are applied, and current is also in the same type of the waveform, so that is applies to this coil, and this coil is wounded around a ferromagnetic material. So and in between we have the blood vessel. So in our body we have blood vessels, and those blood vessels will be placed in between this magnetic core, and the induced EMF will be the generated or induced EMF will be collected to electrodes here. These two electrodes, from these two electrodes we will collect the generated voltage or induced voltage. So what type of waveform we are applied, so that according to that the flux will be generated, and depending upon the velocity of the blood flow, and the type of the waveform we are applied. So according to that, so we'll get the voltage across these two terminals. That voltage is proportional to the amount of the velocity of the so here the blood velocity, depending upon blood velocity. So the here the voltage generated between two electrodes will be amplified here, and here we have a gate here. So here we can have an arrangement that oscillator will be produces the signal for this coil, and also at the same time it will produces the signal to gate. So here this gate signal will be, this is the output of the um, electromagnet. Okay, so that signal will be amplified here. So this is differential amplifier. So it will take difference of the generated voltage, and from that it will be applied to gate. So here it will be, so depending upon the oscillator signal and the obtained signal, it will be check the phase angle, phase variations, and from that it will be applied to filter. So here we will use the low pass filter. So with that we can get the mean value of the signal, and that signal will be averaged. We will get the average output or mean output. So that particular value will gives the velocity of the blood flow of the blood. And so after the gate signal we have a pulse output here. So there are two types of outputs. One is pulse output and another one is the average output. Okay, so these two outputs, from these two outputs we can analyze the velocity of the blood flow. We can analyze the velocity of the blood flow. Okay, so any clarification up to now? Any doubts? Any doubts? Okay, so I am moving to the next one. So the next one is Doppler type of ultrasonic blood flow meter. So ultrasonic blood flow meter and magnetic blood flow meter. These two types of blood flow meters are used while doing the surgery. So these two methods, ultrasonic and magnetic blood flow measuring techniques, are mainly used. Okay, so in the Doppler type of the ultrasonic blood flow meter, so in this we have two types of methods. One is deflection. Here we have transmission and reflection. So in the ultrasonic method, we have transmission and reflection. So based upon two methods, we can use the Doppler ultrasonic blood flow meters. One is transmission type of the blood flow meter. Another one is the Doppler type of the blood flow meter. So in the transmit type of the blood flow meter, so I was already explained at my first class. So the depending upon the transmit time of the, so suppose one side we will send the signal through one side. Suppose we will have a for this transit time of the ultrasonic blood flow meter. So this is the vessel, blood vessel, and one side we will fix the a piezoelectric material. So that piezoelectric material will be transmit the piezoelectric signal, sound sound signal, and that signal will be received at the receiver at the other side of the receiver. So similarly we have, okay, so other side we have a receiver, and one side we will have a transmitter, piezoelectric material, and other side we have again a transmitter. Yes, we have a piezoelectric material. Okay, so whenever the signal is received by the receiver, here the piezoelectric material, when we apply the electric signal, so it will produce as the ultrasound signal, and the other side of the piezoelectric material which receives the ultrasound signal, and that will be converted into the electrical signal. So it is a type of the active transducer. So piezoelectric material is nothing but a active material. So active transducer material. So which converts the voltage to ultrasound signal, and by receiving the ultrasound signal, it converts into the electrical signal. So sound signal to electrical signal, and electrical signal to sound signal. Okay, so in the first type, that is transit type of the blood flow meter, so we will check the we will consider the amount of the time for the receiving of the transmitted signal, and we will calculate the time taken for the received signal after sending the transmitting signal. So in which time, so how much time it was taken to travel through the vessel, and this is the receiver, and the receiving time and transmitting time, those will be calculated, and from that we will calculate the down upstream time. And similarly, if the blood flow is opposite to the transmitted signal, then it is a downstream the downstream time. So those two times, upstream time and downstream time, both will be calculated, and from that difference we will be calculate the velocity of the blood flow. So that is based upon the transit time principle. And the second one, using Doppler effect. So using Doppler effect, so we can use a ultrasonic blood flow meter. You can use the ultrasonic blood flow meter. So this ultrasonic blood flow meter using Doppler effect. So here also we have a pulse generator. So okay, so this is a sine wave pulse generator. You can use it like an oscillator. So generator means it is a oscillator. So it will produce the sinusoidal signal, and it will be amplified, and it will produce and it will be applied to the piezoelectric material, or piezoelectric transducer. We can call it as piezoelectric transducer. So which converts the applied input signal into the corresponding ultrasound signal, and that ultrasound signal will be applied to the blood vessel. So here this is the transmitter, and this is the receiver. So in the place of receiver also we have a piezoelectric transducer only. So these two transducers will be placed opposite to each other in between a blood vessel. So in the blood vessel we have a blood flow will be there. So whenever the transmitter will produce a signal, so that signal will be having some scattering effect. having some scattering effect. So here and it will be due to the blood velocity or blood flow that signal will be scattered and its frequency was changes. Here the generated ultrasound signal having a frequency. So okay, frequency signal and that frequency will be changes due to the flow of the velocity of the blood, and one signal will be received directly without any scattering. One signal will be received without any scattering, and another signal will be received with some deflection frequency. So there is some deflection frequency will be there. So that deflection frequency can call it here, it is a Doppler component. This here it is the FD. Here it is FD. So deflection component. This deflection component may be positive or negative. So it depends upon the direction of the blood flow. Okay, so this Doppler component. This Doppler component is whether it is negative or positive depending upon the direction of the blood flow. Okay, so here this receiver will receive both the signals, and according to that it will be identifies and it will be compares different frequency. If the flow velocity will be very high and deflection scattered pulse frequency will be changes. So depending upon the velocity of the blood flow, the Doppler component will be changes. I mean it will be effects. The change of the Doppler component will gives the information of the blood velocity. So that will be here again we have to make an amplification of this signal, and here it is detected. Here it is a detector. So detector will be detects the difference of the and here it is a detector. Here we are applied a sinusoidal signal here, and here it will be by using rectification process, so it will be converted into a DC signal, and that DC signal will be applied to some speakers, or we can directly apply to some frequency meter as an output. Okay, so the obtained output waveform having frequency components. Okay, and that frequency component is FD. FD is the difference Doppler component. That Doppler component is regarding the variation of the velocity of the blood flow, how much velocity it is moving. Depending upon the velocity of the blood flow, the FD will be changes. So that variation of the blood flow velocity will be reflects on the Doppler component, and that Doppler component will be identified here, and it will be heard by some loudspeaker. We can heard like a type of the sounds, because it is having low frequency components. That's why you can heard just like a sounds like we can observe. Okay, and by using frequency meter we can measure the how much frequency the deflection component will be there. Okay, and that will be that will be noted as an output, represented as an output. So like this we have two types of ultrasonic blood flow meters. So one is transit time ultrasonic blood flow meter, and another one is the Doppler type of the ultrasonic blood flow meter. So here these are the two types using Doppler effect, using ultrasonic blood flow meter. If there is any clarification required for this one, any doubts regarding this one? Okay. So in this today's class, we will conclude that so blood flow measurement or blood flow velocity is one of the important parameter for the human being when where there is a surgery like that, and other we can use in a clinical applications. Okay, so in such situation it is required to measure the blood velocity. So generally there are four types of uh, there are different methods are there. Based upon that basic principles, this blood flow